everyone. I think we're going to get started here. So good afternoon, everyone. My name is Max Thauer. I'm a senior consultant at Mandiant. And today we're going to be talking about Log4j, specifically some incidents that we've responded to, specifically on VMware Horizon servers. So kind of our agenda for today, give you the obligatory spiel of who I am, why we're maybe here. We'll talk a little bit about how it works, specifically an overview of kind of the exploit chain and the CVE. Then we'll kind of dive into three different scenarios. Number one, looking at persistent access via a web shell. Number two, looking at a Cobalt Strike beacon. And then number three, looking at a crypto miner. And kind of with each of those scenarios, talk about some forensic artifacts that might be useful to basically identify this activity as it happens. And then finally, we'll jump into some detection and prevention, basically talking through some pretty commercially available EDR tools, things like that, and ways you could basically identify this activity in those tools. So kind of obligatory disclaimer, the case studies that I'm going to present here are drawn from our experiences and activities working for a variety of customers. They don't represent our work on any one specific customer. I will say in particular, each of these instances that I'm going to cover kind of cross multiple verticals and things like that. So it's not necessarily specific to one distinct group or vertical. And with that as well, all the samples, IPs, everything are available on VirusTotal. So there's nothing really proprietary here per se. If you wanted to go kind of study this yourself, it's widely available. All right, so a little bit of a background about myself. Like I said, I work at Mandiant in their IR group. I basically do IR, incident management, digital forensics. My January of this year was consumed by Log4j, as you could probably imagine. And there's my email and Twitter handle if you're interested in getting in contact with me. All right, so as far as the criticality goes, can anybody name, maybe besides VMware Horizon, which was mentioned in the abstract, at least, one other product that uses Log4j? Sorry? Yep, yeah, it's an Apache product, but basically, I would say aside from, specific Apache products, there are quite a few commercial products that use, Log4j under the hood, primarily because, they're written in Java. It just kind of goes to show Log4j is actually pretty widely used in a lot of stuff. So as you could probably imagine, the fallout is pretty significant. All right, so to kind of talk through the overview of it, it was assigned CVE 2021-44832, kind of dubbed Log4j, Log4Shell. But basically back in November of 2021, an Alibaba researcher identified the bug, basically reported it to Apache. Around December 6th, there's basically, I guess, the first patch per se. We start seeing the proof of concept exploit code published on places like GitHub on December 9th and 10th. Then on December 13th, Apache puts out a second patch. As some of you probably know, it was a little bit of a rough, I guess, patch release for Apache. But it's kind of a hard thing, to basically correct this kind of problem. So, I do give them, some credit per se. So kind of as a Log4j, at a high level, it's basically a logging library. So, people ask me, why would somebody, want to use Log4j? Why do products have to use Log4j? And basically the analogy I give is, why reinvent the wheel, right? If you have, something that basically allows you to, write logs, things like that, when you're developing Java programs, why, reinvent the wheel when you just have something that works great, right? I do, some Python scripting and things like that on the side. And, anytime I can find a great library that basically, solves exactly what I'm trying to do, so you can basically just, script it up in 4 lines, it's super, right? So, again, don't reinvent the wheel if you don't have to. All right, so to talk about the exploit chain a little bit, Basically, the way it works is you have an incoming request, to a victim web server, right? So something that's running, directly on the internet. And basically, in that request, you have this JNDI exploit string, and kind of cascading down from there. There's going to be some instructions for basically a stage 2 of the payload, right? So JNDI stands for Java Naming Directory Interface. Basically, it's a way, to provide APIs, to whatever's running, within Java here, right? So in particular, Log4j, there are some instances where it could pull a payload via DNS, but I think notoriously it has used LDAP, so TCP port 389, but effectively, as the malicious request is sent, you have this JNDI string, calling, basically making an LDAP query, calling for, what's basically a malicious payload, from a remote host. So Log4j, it sees this JNDI string, pulls that LDAP, or makes that LDAP query, and basically pulls the payload in the request. The server that's hosting that payload would respond with the information, containing a malicious Java class. So in particular, this payload, kind of file right here that would be hosted on the malicious host. And then basically, the victim web server would download that, malicious Java class and execute it. Right, so to kind of rehash it, multi-stage exploit. You basically have, the inbound request to, the vulnerable web server with that JNDI string. In that request, it's calling for a stage 2 payload. Sometimes that payload is hosted on the same server that's invoking the original request, but not always. But, generally, if you could see, the JNDI string calling back to the same originating IP, just maybe at a different URI. And then basically once that payload is pulled, in that stage 2, it's basically executed on the victim host, which would give the threat actor something like a reverse shell or, that kind of, post-exploitation. So I did not go the extra mile to basically make my own graphic here. I will say though, I came across this one that's made basically by the Swiss CERT. And I think it really illustrates, the kind of attack lifecycle of Log4j pretty well. And basically some ways you can, block it or, prevent it per se. So in particular, I'd like to, basically start with number 1. You can always, have something like a web application firewall in front of the application, which will, basically look for, strings in those requests that are coming in. And, if it has, for example, like that JNDI string with, a server and then, basically the path to the exploit, you can basically block that. There's some other things you could do as well. Obviously, I think in a lot of commercial software products, it's pretty much, impossible to say, well, I just need to like turn off Log4j. So for example, like let's say if you were running a VMware Horizon server, I wouldn't really think it's feasible to, basically go ahead and, do some of these other things that are suggested here. But nonetheless, these are some, steps you could take, if you were like a software developer per se, kind of rolling your own code or something like that. But, just some other quick things, you could disable Log4j altogether, use a different library, patch it, which is, probably I would say the most logical thing to do. Disable JNDI lookups. Again, if you're not the author of the program, it's not exactly feasible. Disable remote code bases. Again, if you're not the author of the program, not exactly feasible. All right, so to kind of step back a little bit, who is familiar with VMware Horizon? Has anybody used it before? I'd like to see that. Yeah, so basically it's, VDI infrastructure or, like remote application infrastructure for, let's say like remote workers. So in, the, current time of, pandemic and things like that, obviously IT departments have to make applications available to remote users. You can do a lot of things, right? You can have a VPN, you can, give users RDP desktops and things like that. Or you could set up something like a VMware Horizon server or Citrix or something like that, right? So, instead of, giving somebody maybe a full desktop, you can just push, an application to them specifically, right? So let's say, for example, I just wanted to, give a user access to like calc.exe. You can basically do that with VMware Horizon. It would basically just launch a little window once they connect and give them access to that small application. I don't really know why that would be super useful, but you can. But effectively, under the hood, VMware Horizon runs an Apache Tomcat web server. And basically that process that is running the Tomcat web server is this ws tomcat service.exe, right? And I think this is kind of critical because as you see in kind of some of the next slides here, this is basically the web server process that will, when exploited, spawn other malicious processes. All right, so for scenario number 1, so around December 23rd of last year, we observed some string insertion on this absgworker.js file. You can basically see the path there, but basically what this file is the VMware Blast Secure Gateway Service, right? So effectively it's a pretty lightweight Node.js app that relies on this file to function. So it's effectively running I guess the web component of VMware Horizon, right? So basically what we saw is you have that ws tomcat service.exe process spawning a malicious PowerShell process, and in the malicious PowerShell process, what you can actually see is some sort of string insertion. Basically, so this absgworker.js file gets updated, sorry. So if you actually look at, the upper right box here, you can basically see it's kind of a baby web shell, if you will. Basically saying, if the request includes, this long string right here, enter a try, reply with a, HTTP 200, and then basically spawn a child process of, some other data that is also in the request. And otherwise, return a 400, basically stating that it didn't work. Right, so if you actually look at, the difference between the two files, on the left you have basically the updated file, versus on the right is kind of the, more vanilla version that VMware would ship. So what's actually kind of interesting is in a lot of the cases that we investigated, you would actually see, multiple, I guess, string insertions of the same, several lines of code. So I think I actually had like one system in particular that we looked at where it was inserted like 8 different times. So you could kind of hypothesize that the exploit was actually run 8 unique times against the host. But basically, you can kind of see side by side a comparison of the two. So to just kind of talk through, some forensic artifacts on this one in particular, I, generally like to start in Windows event logs anytime I'm looking, at a disk image or something like that. In particular for this one, Windows PowerShell logs, event ID 400 or 600, generally always helpful. Another good one, specifically, I think for this instance in particular, if you look at the system event logs, specifically a 7036 event, which is a service starting or stopping, you can basically see kind of in the, trailing end here, you have the service that will be restarted, right? So, if you think about as you update, this absgworker.js file, you'll basically have to reinitialize it and load it in to the program for the web shell to work. So, basically by restarting that service, the threat actor is able to do that. So, basically you could look for the service starting or stopping. Obviously some other stuff you could look for, a process creation if you have that level of auditing turned on, and then you could also look at something like PowerShell transcripts, which would basically show, the, I guess, underlying PowerShell command that's being run. So kind of an interesting one as well. In our, disk analysis, we basically would take something like, a forensic image of the system, and you could drop it into whatever, kind of forensic suite you like to use. But you can obviously see the, this .js file being modified. And interestingly enough, I see that the file's modified as I'm kind of timelining things. And you say, okay, and you go, look for the hash on VirusTotal, and it comes back completely clean. So, I think it's interesting to note, people kind of trust VirusTotal as being this, perfect way to, determine if something's malware, but it's really only as good as, the vendor signatures are. But you can actually see later in February, I did have 23 detections. So, just kind of naturally with time, things will become updated, and it does gain some detections. All right, so for scenario number 2, basically this one in particular was a Cobalt Strike beacon. So as you can see here, you basically have PowerShell.exe running some encoded PowerShell. So basically, we dive in and try to figure out how to decode it. So enter CyberChef. There's actually a pretty good talk about CyberChef yesterday, I believe. Definitely an awesome tool. But for those that aren't familiar with it, it's basically a way you can encode or decode any sort of input you put it into the tool. So basically, let's say if you had strings, files, things like that, you can do a variety of operations on whatever that data stream is, and then basically get something out on the other end. So in particular, we're just going to go and kind of take this base64 encoded blob and drop it into CyberChef. Right, so we basically load the base64 recipe, and then we decode it, and we basically get what is some human readable text. Right, so we can basically see what it's doing here. It's running invoke expression, and it's pulling a payload from this 185 IP right here. And of course, it's a 185 IP. It just seems like anytime I run into one in forensic analysis, it's generally always bad. But in particular, it's basically pulling a payload from this IP on port 8080 and looking for this DRV file. Right, so let's say, for example, if we actually go and fetch that DRV file, you can see kind of the hash here, but in particular, the file has seemingly a lot of comments in it, which is kind of weird, I guess, for PowerShell. Doesn't really do anything, it just adds bloat to it. But we're basically interested in decoding any other parts of the file as well. So in particular here, you can see there's another snippet which basically states that there's a base64 encoded string. So we're going to basically take that part of the snippet, and then we're going to kind of work on decoding that some more. All right, so we copy paste it, pop it back into CyberChef, decode it from base64, but it just kind of appears to be a bunch of mumbo jumbo text. Doesn't really mean anything to the human eye, right? But I think specifically as it pertains to Cobalt Strike, you kind of have to be a little bit familiar with how to decode payloads and things like that. But a really common obfuscation technique that it uses is basically XORing the payload with decimal key 35. So if you actually take the XOR operation within CyberChef, you can actually just put in key 35, select decimal, and you're actually starting to get some more human readable text. So stepping back for a moment, if you wanted to just search that resulting payload, you could actually add another operation to CyberChef, basically get your MD5, go search the MD5 in VirusTotal, and sure enough, you have something that looks like shellcode, possibly Cobalt Strike, with numerous detections, all good. Otherwise, what you could do is kind of erase that MD5 operation, and then you could go ahead and just save the file, via the save function in CyberChef, and basically we could save it to something like beacon.dat. Right, so then we have that shellcode payload downloaded. You could drop it into numerous kind of shellcode debugging tools, but in particular this one, we can see that it will basically kind of pull out that C2 IP from the payload itself. Basically, for those that remember, it's the same IP that delivered the payload initially. So you can do a number of things with it. Obviously, you can use some sort of command line tool on your own system. You can submit it probably to a sandbox, and it will tell you exactly what it does. We have sandboxes for everything. So basically tell you, it's a Cobalt Strike HTTP stager. It'll give you the user agent, the IP, all that. But if you actually look at, just kind of the, raw decoded part verbatim. It's kind of interesting is obviously you have number one, the user agent. But number two, you also have what's known as an ICAR string. For those that aren't familiar, ICAR is a way you can test if your antivirus is working, right? So if you just go on the internet and Google ICAR string, copy paste it, and put it in like a text file on your desktop or whatever, and save it, it will set off your AV, right? So it's basically just a very common, easy way to test it and make sure things are working. And then finally, you have also your C2 here. But basically, what's kind of interesting about this sample in particular, the ICAR string is packaged into trial versions of Cobalt Strike. So the threat actor that actually went out and deployed this, they use a trial version of Cobalt Strike, and they probably didn't know that this was the case. So it's actually kind of silly in some regards. It just goes to show you kind of like your varying levels of sophistication with threat actors. All right, so to look at some additional artifacts, kind of aside from decoding that payload that's pulled via PowerShell, obviously we found the original evidence of exploitation, kind of in those PowerShell event IDs 400 and 600. But in particular, we also had at least one customer that had sysmon enabled on the actual victim machine. So specifically, if we look at event ID 3, you can see, as the first event, you have network connection to the 185 IP on port 8080, which makes sense because this is basically the first part, where the payload is being pulled. That DRV file hosted on port 8080, and then as time goes on, basically like 1 or 2 seconds later, you have another check into that 185 IP. But on port 80, so basically, this is the payload being pulled, and then the secondary check-in would be the actual C2 communication. Oh, sorry. All right, so for scenario number 3, so this one in particular was a cryptocurrency miner. I would say pretty clear as day. Basically, what you can do is you have, PowerShell, invoke expression, basically pulling this, PS1 file from this, 80 IP here. So, PowerShell file, it's, pretty easy to, read with your eyes. You don't have to like decode it or anything per se. So in particular, this one, you can see a few variables are set at the beginning. Specifically, we have, that same 80 IP as mentioned in the initial pull, set as the variable CC, likely, command and control or something like that. They have a couple other, variables being set. It looks like, some things, for some other file paths. It looks like, turning off the firewall, things like that. But effectively, what it's going to do is basically enumerate running processes on the machine. And if it identifies processes that kind of match a specific name, it will basically stop those processes. And a reason why it might want to do that, for example, if you wanted to run a cryptocurrency miner, you want it to have ample CPU resources so it can actually mine the cryptocurrency and make you money. So basically by stopping specific processes that might match already running miners or other high CPU utilization processes, it can basically achieve its goal. And then it will basically look through some specific established connections. So basically it will run netstat -ANO and basically find TCP connections, and then basically iterate over all of those and specifically look for what's typically a cryptocurrency mining pool destination port. So it's something like 3333, 4444, etc. But basically you can see if it's going to match on any of those destination ports, it will basically stop the process. So again, to give itself more resources and things like that for mining. All right, so from then on out, it'll basically go ahead and pull some additional files, and then basically, as those files are pulled, things like that, it will start the new, I guess, mining process per se. So some other kind of, I would say, pretty good indicators that it's a crypto miner. You basically have the donate level, you have the various, mining pool addresses. So you have a domain, a couple IPs, and then you basically have kind of this U flag here, and this is basically, I guess, like the miner's ID or, like the miner's wallet address. Basically, as you join a, cryptocurrency mining pool, the pool has to know how to, pay you out as a miner, right? So this is basically your, string or address that you're identifying as, when you check into the pool so that you get paid out accordingly. Then obviously, hide it from the user so the user doesn't see it. And then finally, it will add some persistence mechanisms. So specifically creating scheduled tasks, add registry run keys to basically, make sure the mining process would start upon reboot. All right. So getting into some, additional details, I've kind of talked, at a high level about, some, generic ways we can identify, each of these in Windows event logs. I would say in general, there's a lot of, fun things you can find in event logs when you, do forensic analysis. Generally, I kind of, focus around using a couple different software suites in order to actually read the event logs. But I guess just natively, you can use obviously PowerShell or, Windows Event Viewer to kind of, click through logs if you would like. I'm personally a pretty big fan of Event Log Explorer, so it kind of requires you to know a little bit about, what logs and what event IDs you're looking for. But it gives you actually like a pretty good way to filter and kind of, do, I guess, event log analysis at scale. Another kind of cool one as well, there's a tool called Deep Blue CLI. I think it's put out by Sands, and one of my coworkers made me aware of it just maybe like 2 or 3 months ago. But it'll basically, you can kind of throw like the kitchen sink at it when you're doing event log analysis, and it'll actually show you like anomalies and things like that in the Windows event logs, which is kind of cool. But basically, there's some common Windows event IDs you might want to focus on. Specifically something like a security 4624 would be for a logon, 4625 would be for a failed logon, 4688 for a process starting, and 1102 for security event log being cleared. As far as system goes, 7036, which we already talked about a little bit, but this one would be for service starting or stopping, and then also something like a 7045, which would be for a service installation, right? So if you had a piece of malware that you wanted to install as a service, so that it has persistence, it would basically be recorded in the Windows event logs. Obviously, PowerShell is good as well. You can basically, look for something like a 400 or 600, but that's going to basically show you kind of the, script block logging and, the actual command line that's being run. And then if you also have sysmon enabled on the machine, I won't go into the details of each of these, but can basically give you some additional, useful info if you do have sysmon installed. So you can see right here in particular, there's just a couple examples of, some commands you can run to basically find, what you might be looking for, just from the Windows, event log commandlets that are built into PowerShell. All right, so as far as, detecting this in, kind of commercially available tools, in Windows Defender ATP, it's pretty cool actually, can kind of just, detect it out of the box for you. So here you have an example of, Log4j, exploitation being detected. But if you wanted to, for example, to like go in and actually hunt for, suspicious, process telemetry and things like that, basically what you can do is look for that WS Tomcat service.exe and basically look at all the child processes that it's spawning. So in particular, VMware Horizon, it will use repadmin.exe to basically replicate data between itself and other VMware Horizon servers. So if you like cluster them or whatever, but in particular, you can filter out that executable and then just kind of watch for other services that are, or other processes that are spawned. So for example, if you had something like a command.exe or a PowerShell.exe being spawned out of WS Tomcat service, you probably want to look into that. And additionally, you could look at something like, PowerShell.exe, basically, having something like the VMblast SG in the process command line, which would basically, indicate that PowerShell is restarting that VMblast service. All right, so for CrowdStrike Falcon, again, it's pretty, I would say, repetitive these next couple slides, but just kind of goes to show, you will have that WS Tomcat service.exe basically spawning, something like a malicious PowerShell process. And you can basically see here, like most EDR tools should, it will kind of detect that that is being done, basically terminate the process. In Carbon Black, kind of cool, you can, search for the CVE and identify, basically instances where it might be in use. But again, just kind of reharping on that same parent to child process relationship, you have the WS Tomcat service.exe, spawning a PowerShell process. You can see kind of in the details pane here, you do have an encoded command, but good enough for us. The process, is basically being denied. So, the actual malicious PowerShell process is terminated. Specifically in FireEye HX, it will detect kind of out of the box, suspicious PowerShell methodology. So basically, looking for encoded PowerShell and things like that. But again, to just kind of rehash it, you have that WS Tomcat service.exe, basically launching PowerShell, and then you can see as a command line argument, you basically have that encoded command, which will basically go and fetch that stage 2 payload. So kind of another cool one that I didn't have a lot of experience with, but one of my customers, had it and it, made it available to us. So basically, Dell SecureWorks, they have kind of this new Taegis XDR. I think, basically you take all of the Red Cloak agents and you basically feed the data in to this now. But kind of cool, it actually detailed, a lot of the incidents and I guess, exploitation campaigns, that we covered in the talk here. But you can actually see here, what was kind of cool about this one, is it actually captured some, I guess, follow-up activity with regards to the web shell that was placed. So in particular, you can see, very similar to the first scenario we talked about, you have, kind of that, web shell string insertion, and then, basically the restarting of that VMblast SG service. And then basically you can see about 1 day later, you actually have somebody coming back and then running a command, .exe, basically running the whoami command. So kind of cool actually that it will track all the subsequent process executions that come out of that web shell. And then you can basically see it has some other detections for like the 185 IP, which is the Cobalt Strike IP we also talked about. All right, so as far as prevention goes, there are a couple of ways you can, try to block this or, hope to block this. Say, number one, you just have to kind of stay up to date with patching and things like that. I would say in an instance like Log4j, you're not always going to have, the patches that are, maybe readily available, as exploit code drops. So, there's not a ton you can do about that. But, I guess, kind of stay vigilant and kind of be aware when, exploits come out, for, software, products that you might kind of depend on. Say also, vulnerability scanning. I really, try to emphasize this to all my customers. You kind of have to really, really know your perimeter. We all, for example, we'll run, services to make them available to our users and things like that. But if you don't actually, understand that, you have dependencies and vulnerabilities, and you're basically running, those items directly on the internet, it's going to get exploited, if there is, publicly available exploit code for it. And it's just kind of a matter of time until you enter a scenario like this. So again, know your perimeter. There's a lot of tools that will kind of help you map your, attack surface, specifically for what you have on the internet. If anybody wants to talk about those, after the talk, I'm happy to chat a little bit more about those. But some other things you can do, kind of like what was referenced in the Swiss government's cert. You can run it at web application firewall, so it's something like an Imperva, Cloudflare, or Akamai. I would say egress filtering is also a pretty good one. So I dealt with one customer in particular. Basically, they had an instance where stage 1 of the exploit was running, so we could obviously see the inbound request being sent to the VMware Horizon server. However, the stage 2 would, I guess, never complete, or the server would never effectively be exploited. Specifically because they were filtering kind of for outbound connections on TCP 389. So it's actually kind of cool. You can have the exploit be delivered, but since it has to go back and basically pick up that I guess second stage, there's not actually a way for it to do that since they're doing egress filtering, which was actually kind of cool because we basically didn't have an incident. So always love to kind of see that. So again, watch for some outbound connections to seemingly suspicious IPs and domains. Namely, I find a lot of threat actors will use something like a canary token to just test if there is something vulnerable. So basically, looking for something like a ENS request to a canary token domain coming from a VMware Horizon server. We're also looking for basically outbound connections on TCP 389. And for those that aren't familiar with canary tokens, it's basically kind of like a mini honeypot, if you will. So let's say, for example, kind of in the screenshot here, if you had, if you wanted to set up like a canary AWS key, what you can do is kind of generate one and then just basically be notified anytime that key is used. So, you can have it like email you can have it, send a request to a webhook, a lot of different ways, but, kind of a cool way to, detect, if something is being used that shouldn't be. Some other things, you can obviously kind of depend on your EDR. And I would say, if you're going to run services on the internet, it's important to have, some way to kind of monitor process telemetry so that you can basically identify when something like this happens. So, most EDR products, can enable you to do that. Then alternatively, you could disable something like JNDI that's referenced here in, the Swiss certs, great graphic. That being said, though, if it's a commercial software product, they probably won't give you the ability to kind of do that, out the box per se. So, I think in that regard, you're kind of dependent, specifically on the vendor, and you might want to, kind of revert back to number one, blocking it with the web application firewall, or obviously patching it as well. And then finally, some threat intel items. I think, a lot of EDR products and next generation firewall products will kind of bundle, detections for this kind of activity directly into the product. So if you think about, a lot of the organizations that make these products, they have, pretty big research teams and groups that will basically, track this activity. So, I think you will get some good coverage there. I personally like to, read Twitter a lot. I'm not really a poster, I'll admit to that, but I definitely, try to absorb as much as I can there. What's kind of cool about each one of these incidents in particular, if you just go Google, the IPs, you'll find Twitter threads that are kind of talking about this activity as it's happening, right? So, it's not really anything super special, but it kind of goes to show that, if security researchers can kind of find this activity as it's happening and kind of, broadcast it to the whole internet, we can kind of, collectively, fight back against the attackers, which I think is great. Shameless plug for Banyan Advantage. As security professionals, it kind of operates on a freemium model. So if any of you want accounts, you can, go and register for that, get some information from there. And then finally, just some IOC links, for kind of pretty common feeds as it pertains to Log4j. So with that, does anybody have any questions? Anything at all? Sure.
Can you talk a little bit about the sophistication of one of the actors? Did you or maybe do any like additional work towards attribution? Did that matter?
Yeah, so I would say in these instances in particular, the attribution, they were basically all attributed to be new groups. So I'm not sure if you're familiar kind of with the way that Mandiant tracks threat actors, but we basically take new groups and we specify them as an UNC cluster, and then as we have evidence to basically link varying groups, we kind of merge them together. But for all these in particular, they were, I guess, individual, new UNC groups per se. Sure. Yep.
With regards to Log4j, if it is, I have worked previously with a program where Log4j was present but not being actively used by the software. It was just a configuration people could turn on.
Mm-hmm.
If you turned that configuration off, but the file was just there, would it still pose a threat?
Like the webshell file in particular, or?
Yes.
Yeah, so I mean, if you think about that, that's basically using Log4j to put kind of like a secondary backdoor on the system, right? So I would say from then on out, the matter of I guess executing commands on the system as the threat actor, you're not really depending on Log4j anymore because you have that kind of light piece of malware, I should say. So like if you were to, I guess, have Log4j turned off from the get-go, the exploit chain obviously wouldn't work. But once I guess the piece of malware is there or a Cobalt Strike beacon is there, it's effectively game over, and you have the threat actor can have access to the system.
Gotcha. So it was never activated in the software to begin with. It would be safe, but if it was activated and someone put Cobalt Strike on there, you can't turn it off.
Right. So like if you, for example, that's correct. If you didn't have it, I guess, enabled in the first place, you wouldn't be able to exploit it, to basically have the downstream effect of something like Cobalt Strike or a web shell. So, you wouldn't basically be facing the problem.
Thank you.
Sure. Anyone else? Super. Well, thank you. And yeah, if anybody wants to chat after, happy to talk about, anything offline too. But thanks, everyone.